Hello student, how are you? I'm arunsir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you the equilibrium of a ball in a rough rotating hemispherical bowl. Both for smooth and rough hemispherical bowl I will discuss. So today's topic is equilibrium of a ball in a rotating hemispherical ball in smooth. First I discuss in smooth bowl and then I discuss for rough bowl. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET exam confidently with a good rank. Now let's start about the class. First I will discuss for equilibrium of a ball in smooth spherical bowl. For so suppose this is a smooth hemispherical bowl. This is a smooth hemispherical bowl and a ball present at here. The hemispherical bowl is rotating about the vertical axis with angular velocity omega, and the ball is present at this position and it is rotating in this circle. It is rotating in this circle. So the ball is rotating in this circle, that is r is the radius of the circle and capital R is radius of the hemispherical bowl. Now this angle is suppose theta. This angle is suppose theta. That is hemispherical bowl is that is the ball is in equilibrium at an angle theta. Theta is measured with vertical axis at this angular position. This. So this is the angle theta. Now that we draw the tangent at here. We draw the tangent at here. We draw the tangent at here. This angle is 90. This is theta. So this angle is 90 minus theta. 90 minus theta. Now we know the normal reaction is along this. What is the normal reaction? The particle is at here, so normal reaction act in this direction and weight act vertically downward. This now this angle is 90 minus theta. So this angle is 90 minus theta and this is 90. So this angle is theta. This angle is theta. So mg cos theta is in this direction and mg sin theta in this direction, and the ball is rotating about this circle. So centrifugal force act in this direction m omega square r. Now the radius is r here. So for first considering the smooth bowl, we resolve this force along this direction and this direction. This angle is theta, so this angle 90 minus theta, and this is 90 degree because this is radial line and this is tangent. So total angle is 90 and this is 90 minus theta. So this angle is theta. So component of this force along this is m omega square r cos theta, and in this direction component is m omega square r sin theta. So normal reaction is n. So first write what is the normal reaction at here. Normal reaction equal to m omega square r sin theta plus mg cos theta. This is normal reaction. And also what is the relation between small r and capital R from this triangle, that is O. Suppose this is C, this is point A, OAC triangle. From triangle OAC, the value of sin theta, if we write sin theta equal to small r by capital R, this by this, okay, sin theta equal to this by this by this, for which r equal to r sin theta, Now for equilibrium of the ball, this force must be equal to this force. So m omega square r cos theta equal to mg sin theta. Okay, now cancel this. So omega square value of omega value will be g sin theta by r cos theta root over. Now put the value of small r equal to r sin theta g sin theta into cos theta, cancel sin theta, so the result is root over g by r cos theta. So here angular velocity omega equal to this is the answer. And if you are asked to calculate the normal relation, what will be the normal relation? Small r equal to r sin theta, we get small r equal to r sin theta, so r sin theta plus mg cos theta. So this is the answer. Now for rough hemispherical bowl. For rough hemispherical bowl, equilibrium of a ball for rough equilibrium of a ball for a equilibrium of a ball in rotating rough hemispherical bowl. So consider this bowl. This is this bowl is rotating with angular velocity omega, and here a ball is present at an angular position theta. Theta is measured from vertical axis. This is theta. Okay, this angle is theta. Now what is the different force acting on the ball? If the ball is rotating with angular velocity omega, what is the different force acting on the ball? First, weight of the ball act downward, and centrifugal force, as the hemispherical bowl is rotating, so the ball describes this circle, and so a centrifugal force act in this direction, which is m omega square r, where r is the radius of this circle. Now here friction force is present, so we resolve along this is tangent, we resolve m omega square r along this direction and perpendicular to this direction. So what is the angle? If this angle is theta, then this angle is theta. How? This is corresponding angle, this is vertical line, this is vertical line, and this is vertical line, and this is a transverse, so theta same. So this is theta. Already also we get this is 90 minus theta, this is theta. So anyway, we get if this angle is theta, then this angle is theta. This is corresponding angle. Now resolve this force along this and this. So if this angle is theta, then this angle is 90 minus theta, and this angle is theta. Okay, because this and this is perpendicular. This and this is radial line, and this is tangent line. We know the angle between tangent and radius is 90 degree. So total angle is 90 degree. This angle is 90 degree. So if this angle is 90 minus theta, we get this is theta. Now resolve this force along two components. This is cos theta, and this direction is sin theta, and resolve the weight along this and this direction. This is m omega mg, so this direction is, so component of this along this direction is mg cos theta, and in this direction is mg sin theta. So friction force. Now to calculate minimum omega minimum, if the ball is rotating with minimum angular velocity for which the ball can in equilibrium, that is the angular velocity, minimum angular velocity, for this the ball is at rest. Now what is the friction force acting in which direction? Friction force acting in which direction for minimum omega? If omega is minimum, then this force is minimum. this force is minimum, this force is minimum, so minimum force act. Now weight, this is constant, mg sin theta constant, so this is minimum, so friction prevents this weight, so friction must act in this direction, so friction must act in this direction, this is friction. So if weight is act in this direction, friction must prevent this direction because this is less force, so this is less force, this and this and friction both combined prevents the weight of the ball. So here equation will be m omega square r cos theta plus friction prevents the mg sin theta. Okay, now m omega square, what is r? We know from this small r, this is capital R, so sin theta equal to small r by capital R, so r equal to r sin theta, so m omega square r sin theta cos theta plus friction equal to mu into n. Now what is n? Normal direction act in this direction, so here normal direction will be this plus this, mu into n equal to this plus this. Okay, this plus this, so m omega square r equal to r sin theta, r sin square theta plus cos theta. So this, now this is normal direction equal to mg sin theta. So now from this equation we calculate omega. So if we take common m omega square r sin theta, then we get m omega square sin theta, we get cos theta plus mu sin theta, this equal to this mg sin theta minus mu mg cos theta, we get this equation. So we get omega square equal to mg sin theta minus mu cos theta divided by mr sin theta cos theta plus mu sin theta, we get this. So cancel m in both side, so if we this is the answer, so this is the answer, omega equal to root over this. Now if we simplify this, mu equal to tan lambda, then we get g sin theta minus tan lambda cos theta divided by r sin theta cos theta plus tan lambda sin theta. What is now lambda? We know lambda equal to angle of friction, and result is mu equal to tan lambda. We know mu equal to tan lambda is a formula. So if we simplify, we get g into sin lambda by cos lambda, sin theta minus lambda by r sin theta, sin lambda by cos lambda, cos theta minus lambda, cos a cos b, sin lambda by cos lambda, sin a minus b, sin lambda by cos lambda, cos a minus b. So this is the answer. So omega equal to g by r tan theta minus lambda by sin theta, we get this root over this. So this is the result for, this is the omega minimum, Now if we get the maximum velocity, then the friction force will be reversed. So for maximum velocity, this is a hemispherical bowl, Now this angle is theta is given. So if this angle is theta, then this angle is theta, corresponding angle. Now we resolve mg in two component. First we resolve mg in two component. This direction is mg cos theta and this direction is mg sin theta. Next, what is that centrifugal force? Centrifugal force, the ball rotates. If the hemispherical bowl rotates with angular velocity omega, then this ball rotates with same angular velocity omega in this circle, along this circle. So now the radius, if the radius is smaller, now centrifugal force act in this direction along the radially outward m omega square r. So if this angle is theta, this angle is 90 minus theta, and this is angle is theta, this angle is theta. Now the component of this force along this force is m omega square r cos theta, and component of this force along this direction is m omega square r. This is cos theta and this is sin theta, sin theta, sin theta. Now what is the normal relation? Here normal relation will be mg cos theta plus m omega square r sin theta. Now what is the relation between r and capital R and theta? We know sin theta equal to small r by capital R, so small r equal to this. Put here mg cos theta plus m omega square r sin square theta. So this is the normal reaction. Now what happens if the speed is maximum, that is speed is sufficient maximum, but yet the body is in equilibrium. So here speed is maximum, so centrifugal force is maximum, that is this force is maximum, so the body slip, so the body tends to slip in this direction, so the body tends to slip in this direction. Now so the friction prevents the slipping, friction prevents the slipping. If this angular velocity is maximum, then this force is maximum, this force is maximum, so the body tends to slip along this direction. Now the friction prevents the slipping. So what is the friction force? Friction force act in this direction F. So which prevents the slipping of the this force, because friction is adjusting. Friction can reverse its direction to prevent the slipping of the body. Friction can reverse its direction to slipping of the body. So this, that is, friction is adjusting force. It can reverse its direction, it can adjust its value. Reverse friction is adjusting force. So now if as the body is as the body tends to slip upwards, so friction act in this direction such that friction and weight prevents the slipping of the body, slipping of the ball. So here equation is F plus mg sin theta equal to m omega square r cos theta, m omega square r cos theta. What? Friction equal to mu into n, normal action equal to this, so mg cos theta plus m omega square r sin square theta plus mg sin theta equal to m omega square r. What is small r? Small r equal to r sin theta. We put here r sin theta cos theta. We know small r equal to r sin theta. Put here. Now we have to calculate. So omega square. If we take omega square m omega square r sin theta, m omega square r sin theta. So just all terms this into this. These terms shift left side and this is even same. So this m omega square r, if we take common m omega sin theta, we get cos theta minus mu sin theta equal to here mu mg cos theta plus mg sin theta. So we get omega square equal to mu mg, if we take common mg mu cos theta plus sin theta divided by m r sin theta cos theta minus mu sin theta. So this, now if we put mu equal to tan lambda, so omega square equal to g into cos theta tan lambda plus sin theta by r sin theta cos theta minus mu tan lambda into sin theta, which is we get g by r sin theta, which we get g by r sin theta into, if we sin lambda by cos lambda, so the formula will be sin theta plus lambda, sin theta plus lambda divided by sin lambda by cos lambda, cos theta plus lambda, this. So omega maximum, value will be, so omega maximum value will be g tan theta plus lambda by r sin theta. This is the result. Previously tan theta minus lambda, now we get tan theta plus lambda. So this is the result of omega maximum. This is the result for omega maximum for which the ball is in equilibrium. So today this is the end of this topics. This is the end of the class. To get more such type of video and more important problems on NEET exam and JEE main exam, subscribe my channel. Okay, thank you.